It's time to learn a new word, and that word's multiplicity. But before we define it, it might be better to look at an example. So let's take a look at this polynomial. F of x equals negative x squared times x minus 1. Now, this polynomial is in factored form because it has linear and irreducible terms. Now, x minus 1, of course, is linear, and x squared is irreducible because we can't break that down any further. Now, if we were to multiply this together, we would end up with negative x cubed plus x squared. And so we know we're dealing with a third-degree polynomial with a negative leading coefficient. Let's take a look at the solutions of this and see what the graph looks like. So we set it equal to 0 to calculate the solutions. Now, x squared could equal 0, or x minus 1 could equal 0. If x squared equals 0, then of course x equals 0. And if x minus 1 equals 0, then of course x equals negative 1. Now this x squared has a multiplicity of 2, because it's sort of like you have two x equals zeros there. And I encourage you to list the terms multiple times. Even though it looks repetitive, it can help you remember that that term has a multiplicity of something other than 1. So let's get our graph here. Now, this one has an odd degree, but a negative leading coefficient, so our end behaviors are going to be reversed, and it's going to go up to the left and down to the right. My zeros this time, I've got 3 of them because I have a third-degree polynomial, but 2 of them are in the same place, so I only really have 2 unique zeros. So when I go to graph this, what happens is that where there's a multiplicity of 2, the graph is just going to kind of bounce off that solution. It's just going to touch at that point and go back the way it was coming from. Now with the multiplicity of 1, the graph looks normal and goes through. But with this even multiplicity, this multiplicity of 2, the graph is going to reflect. So the multiplicity, we can determine, is the number of times that you have some unique zero, a specific zero in a function. And even multiplicity causes the graph to go back in the same direction, and with odd multiplicity, the graph is just going to travel through a point. So you may make a note of that right now to the side of your notes so that you just remember, even multiplicity, the graph's going to come back. Odd multiplicity, the graph's going to go through that point and travel onto the other side of the x-axis.